Hey guys, in this video we're given the problem where the position of a particle is given by r of t, which equals t squared, comma 5t, comma t squared minus 16t. So they're asking us, when is the speed or the magnitude of the velocity at a minimum? So we have to understand that we're given the position. And to find the velocity, so v of t, we need to take the derivative of the position function, so r prime of t, which equals, so the derivative, and we're taking the derivative component-wise, so t squared is going to be 2t, the derivative of 5t is 5, and lastly, the derivative of t squared minus 16t is 2t minus 16. Now that we have the vector for our velocity, we need to find its magnitude. And we can do this by using the distance formula. So v of t over here equals the square root of 2t squared plus 5 squared plus 2t minus 16 squared. Now it's much easier for further calculations in this problem not to deal with that square root. So I'm just going to square this function. So s of t, that's going to be what I'm going to label this. You can label it any letter. It can be a of t, b of t, or anything. But for now, I'm going to label it as s of t for squared. So equals v of t, the magnitude of v of t squared, which equals 2t squared plus 5 squared plus 2t minus 16 squared. Simplifying this, I should get s of t equals 4t squared plus 25 plus 4t squared minus 64t plus 256. Okay, and I can simplify this further to get s of t equals 8t squared minus 64t plus 281. Okay, now that we have this, we have to note that because our coefficient is greater than 0 and it is a positive number, our parabola is going to be opening upwards. So we do have a minimum at some point or some time. So now that we understand what we have and where we are, we can now take the derivative. So the derivative of s of t, so s prime of t equals 16t minus 64. And now I can solve for t. So t equals, so 64 divided by 16 should give us 4. So t equals 4. Now what I can do is plug this back into my original right here. Let me highlight this right over here. I can plug this back in over here. So s of t, so I can get so I can get the speed at time equals 4. So that would be s of 4 equals 8 times 4 squared minus 64 times 4 plus 281. When you plug this into your calculator, you should get the square root of 153. So that is what we have for this question. So our answer is time t equals 4 at a magnitude of 153 square rooted.